Hey guys, these are our notes for dividing rational expressions. So we are in our new digital notebook we got this week. You can fill in your table of contents. You need a piece of paper just for a little bit of notes part, and then your workbook unit 2B. So I'm going to put the title at the top of your paper. You don't have to write down the essential question, but at the end we should be able to decide how you divide rational expressions and how it's similar to multiplying rational expressions, which is what we did yesterday. So to start us off, we're going to talk about just how to divide fractions in general, right? So the way you divide fractions is you would have 2/3 divided by 3/5. And what you're going to do is you're going to multiply by the reciprocal of the divisor, okay? You multiply by the reciprocal of the divisor. Well, the second one is the divisor. So some of you may remember this as keep, change, flip. You keep the first fraction the same, you change it to multiplication, you flip the second fraction, and voila, now you have a multiplication problem. So if we're multiplying, we would try to see if anything can cancel on the top and the bottom, and then we just multiply whatever is left over. So we would get 10/9, and that would just be our final answer. So the way that you divide fractions is you multiply by the reciprocal of the divisor, which means you flip the second fraction, change it to multiplication. Okay, so that was what we're going to write down, is how to divide rational expressions. What you're going to do is you're going to multiply by the reciprocal of the divisor. Some of you may remember this as keep, change, flip. After you're done, you now just have a multiplication problem like what we did yesterday. So you try to factor and cancel. And lastly, you just multiply whatever remains. The one thing though I do want to remind you guys is about your invalid values. Since the second fraction gets flipped, you actually have to check the numerator and denominator of the second fraction. So you check for invalid values, extraneous solutions, restricted, they all mean the same thing. So you check for invalid values in both denominators. And the divisor's numerator. Okay, so we're going to take a picture of this. This is going to go into our notebook, our digital notebook. But right now I need you to grab your workbook, and we're going to be on page 39 and 40 for our examples today. So again, this is on page 39. Example number 1 says simplify the rational expression 3x squared over 7 divided by x over 3. So the first one it wants us to do is identify any invalid values. So we already know that we're going to have to flip, but they have us kind of do the second invalid values here. So right now when you look at these, you don't see any x's, so there's no invalid values, there are none. Now we're going to rewrite our problem in step 2 as a multiplication problem using the reciprocal of the divisor. So we keep the first one the same, we change it to multiplication, and we flip it, so it becomes 3/x. Now it says identify any invalid values of the second rewritten, or of the rewritten second term. So now that we flipped it, the numerator went to the denominator, and we do have an invalid value. X cannot be equal to 0. So in the original problem, there weren't any because there was no x's in the denominators. But once we flip the second one, we now have an invalid value of 0. So you do have to try to, check both denominators, numerator of the second one. All right, now it says to multiply the terms of the rewritten expression, we're going to try to factor and cancel. So when I look at the top of the first one, it's 3x squared. That's really just 3 times x because it's a monomial. No plus or minus signs, no parentheses needed. The denominator is 7, that's prime. Over in the other fraction, we have 3, which is prime, x, which is prime. So the only real factoring I did was, multiplying the x and x, or x squared is xx. And then you just look if anything's the same on the top and bottom, you cancel them out. So I see an x on top and an x on bottom. They're not holding hands with anyone. There's no plus signs. There's a 3 on top and a 3 on top, but we can't cancel those because they're both on top. So 3x times 3 is 9x. And there's a 7 on the bottom, and we say there's just one excluded value, x cannot be equal to 0. That's it. So very similar to what we did yesterday. This was a monomial problem. There's no plus or minus signs. Let's go to example number 2. All right, so for example number 2, we have our problem is a division problem. So you keep, change, flip. You keep the first one the same, you change it to multiplication, and you flip the second one, right? Multiply by the divisor of the reciprocal. I'm just going to kind of factor as I go. So the first one has an x on top. Can't factor or simplify that at all, so it's just x. On the bottom, I have x squared plus 1. There's no GCF. It kind of looks like it'd be a squares problem, but it's a difference of squares, so we can't factor it at all. I'm just going to go ahead and put it in parentheses. We change it to multiplication, and now we're going to flip. The 5 that was once on the top now goes to the bottom. The x squared minus x plus 1 that was on the bottom now goes to the top. I notice that it's a trinomial, so I'm going to try to see if I can factor it. A times c is 1, b is -1. So do I have two numbers that multiply to 1 but add to -1? Well, the only thing that multiplies to 1 is 1 and 1. Excuse me. But in order for it to be minus on the bottom, you'd have to have both of them negative. That adds to -2, so it's not factorable. Okay, so we're just going to have to put it in parentheses. It could not be factored. Now let's see if we can cancel anything. I see x's on top and on bottom. Can I cancel them? No, because the one on the bottom is holding hands with something. I see x squared on the top and the bottom. Can I cancel those and like the ones? No, because they're holding hands. You can't break them apart. In order to cancel it, you would have had to not have this piece right here. We can't cancel it. So nothing cancels, unfortunately. It's not as fun when nothing cancels, so we're just going to multiply. So x times x squared is x cubed. X times -x is -x squared. X times 1 is x. On the bottom, x squared plus 1 times 5. X squared times 5 is 5x squared. 1 times 5 is 5, and that's my answer. We do have to check for some invalid values, but since x squared plus 1, there's no invalid values that are real numbers because we couldn't factor it. It would just be imaginary numbers because it would be x squared equals -1 if you tried to solve it. So there's no invalid values. It could be positive, negative, whatever it wants. Let's go to example 3. So I'm going to keep, change, flip, but I'm going to factor as I go. So I look at the top of the first one, x squared minus 3x. I look for GCF first. I notice they can both be divided by x. When I divide both of these things by x, I just get x minus 3, which that can't be factored any further. There's no difference of squares or anything. On the bottom, I have x squared minus x minus 6. I'm going to try to do a little snowflake for that one. Multiplies to -6, adds to -1. Multiplies to 6 is 1 and 6, or 2 and 3. So if I do 2 and -3, that multiplies to -6, and then 2 minus 3 is -1. So x plus 2 times x minus 3. We change it to multiplication, and we're going to flip. So this x minus 3 that was on the top moves to the bottom. There's no GCF, it's no squares or anything. I just put parentheses around it. Then the x plus 2 that was once on the bottom now goes to the top. There's no GCF, I can't factor it or anything, so I just put it on the top. So I look now and I see if anything can cancel. I see an x minus 3 on top. There's two x minus 3s on the bottom. I can only factor cancel one of them. Doesn't matter which one, but only one of them. I also see an x plus 2 on top and an x plus 2 on the bottom. They're not on the same fraction, but I can still cancel them. I see an x and an x, but I can't cancel those because the x minus 3 is holding hands. So it's x over x minus 3. My invalid values, as I look in the denominators, I have x plus 2, so that means x can't be -2. X minus 3 means x can't be positive 3. This one is also positive 3. And then you also look at the numerator, or the original denominator was x plus 2, but that's negative 2. So those are my only invalid values. All right, 2 more examples. All right, my next one says simplify the rational expression. Okay, I have 3 terms. There's no GCF. It is in the form I can try to do snowflake though. So I need 2 numbers that multiply to 14 and add to 9. So multiplies to 14 is 1 and 14, or 2 and 7. Luckily 2 and 7 multiply or add to 9. So x plus 2, x plus 7. I'll try to color code and do each piece. Okay, remember I'm going to keep, change, flip. So the bottom it says x squared plus 7x. There is a GCF there. They both can be divided by 7. That gives me x plus 7, which is not, no, I put 7. Sorry guys. They both have a GCF of x. That divides into both of them. That gives me x plus 7 in my parentheses. That can't be factored any further. Then I have x squared plus x minus 2 was in the numerator. It moves to the denominator. I'm going to see if I can do a little snowflake. So what multiplies to negative 2 but adds to 1? Well, the only thing that multiplies to 2 is 1 times 2. And if you make the 1 negative, that would multiply to negative 2. And 2 minus 1 is 1. So it was on the top. Now we're moving it to the bottom. X minus 1, x plus 2. All right. Then in the last one we have is 4x squared minus 4x. For the GCF, I notice that both of them have a 4 and both of them have an x. I'm going to take out a 4x. When I divide both of those by 4x, I get x minus 1. All right, now from here, we try to cancel. If something's the same on the top and the bottom, we can cancel x plus 7, x plus 7, x plus 2, x plus 2, x minus 1, x minus 1. One more thing, actually. There's an x here and an x here that will cancel, so all I'm left with is 4. That big old problem, everything canceled except for the 4. We have some invalid values, though. There's a bunch. So right here, what would make 0 is 0. What would make 0 in this parenthesis is negative 7. What would make 0 in these parentheses is positive 1 and negative 2. You also have to look at these ones, but that's 1, which we already have written down, and this is 0. So all those things would make 0. Last one is a throwback, throwback to synthetic division, because when you're dividing polynomials, if it's just a monomial, okay, it says x cubed plus 2x squared minus x plus 3 divided by x plus 1. So we can use synthetic division. That's what the problem asks us to use. So we're throwing it back. What you do, or how you decide what goes in the box, is you look at what the divisor is, and you say basically what would make 0. So if it says x plus 1, you put minus 1 in the box. For your coefficients, you make sure you don't have any 0 terms. I have x cubed, x squared, x, and a constant, so I'm not missing anything. So I have 1x cubed, 2x squared, minus 1x, and 3. And we're going to use our synthetic division. You move down the first number, you multiply by what's in the box. Negative 1 times 1 is negative 1. Add, you get 1. Multiply what's in the box, negative 1. Add coming down, we get negative 2. Multiply what's in the box, we get 2. Add coming down, we get 5. So it says in the form of Q, which is the quotient, that's this part right here, and then the remainder, that's what's in your box, divided by BX, which is just whatever the divisor was. So we have our remainder, our constant, our coefficient on x, x squared. So we're just writing our answer as 1x squared plus 1x minus 2, that's the quotient part. And then the remainder would be 5 over b of x is just the divisor, x plus 1. And that's our answer. So it's a throwback to dividing using synthetic division, because that's what these problems are, dividing. Where they go in your notebook is on slide 10. You're going to put your notes part, right? We only had a little bit of notes, so we have an X over here. On slide 11, you put your page 39 on the left and your page 40 on the right, and then you'll do your homework, which is dividing polynomials problems. So hopefully it's getting easier, this factoring and canceling, because we've been doing it for like 3 days now. All right, bye.